The effect of sleeping habits on information processing. Sleep is a necessity for an individual's overall physical well-being. However, our cognitive functions may be influenced by sleep. In 1984, Tilley and Warren investigated retrieval performance on a semantic memory task and sleep by having participants stay awake for an entire night. They found that as sleep deprivation increased, the time taken to retrieve category members from long-term memory increased. A study conducted by Voderholzer looked at the connection between sleep and memory by restricting participants to sleep various hours for 4 consecutive nights. After 2 recovery nights of sleep, participants were tested on their cognitive performance and memory encoding, and no significant difference was found between groups. In 1885, Babcock used the lexical decision task to assess participants' information processing ability while deprived of sleep for 72 hours. The task involves the presentation of a word pair, either related or unrelated, in meaning, and requires the participant to decide whether a non-English word is present. The study found that response accuracy decreased as sleep deprivation increased. A gap present in all of these studies is a lack of representation for the impacts of long-term sleeping habits versus short-term, and the way information is processed into our long-term memory. We conducted a correlational study using a survey made on Sci Toolkits that included a question about sleeping habits and information processing tasks. The survey was distributed through social media and participation was voluntary. Initially, we had 68 participants, but due to incomplete surveys, our final set was 62 participants. Our participants ranged from 18 years of age to 49. 29 identified as female, 32 as male, and 1 as other than male or female. Participants were first asked several demographic questions. They were then asked to report the average number of hours they typically get per night, along with how many hours of sleep they got prior to taking the survey. A sleep score was calculated to represent the construct of long-term sleeping habits. Participants then completed a lexical decision task to measure information processing ability, focusing on stimuli with unrelated words. People tend to respond slower compared to stimuli with related words.
This is due to the way our long-term memory is organized and how the activation of related information from reading one word facilitate the recognition of another related word. For this reason, we hypothesized that as sleep score decreased, average response time to the unrelated stimuli in the lexical decision task will increase. A Pearson's R correlation test was performed, and the results showed that there was an insignificant negative correlation between the variable, which does not support our hypothesis. Shown in the scatter plot, there was a weak negative correlation between sleep score and reaction time of the task. This correlation is too small to consider it significant. Limitations to the study include small sample size, access requirement of the study, and the self-reporting nature of the survey questions. To avoid these limitations in the future, a larger sample size should be included and the task should be accessible to all types of devices. Also, sleeping habits should be measured more objectively.